Rotations. Lesson 78 on page 511. Yes, go. I don't want to have you say it. Alright, on page 5. So we're going 90 degrees about the origin. Okay, we're going to do problems for all of these on page 511. These are the formulas that you need to be able to rotate. If we're going 270 degrees, about the origin. Why did I put dots there? I don't know. About the origin. Your transformation of xy will simply be negative, x, y, negative x. Really? Yes, it is. That's why I'm giving it to you for you to write in your notes. That's why you okay. So you've got these. They're in your book. You've written them down. Okay. So now let's do a few.
Why did the y next?
Because that's where we're rotating them. Okay. So if I give you a shape, here we go. On grid paper, let's have a triangle. Yeah. So here we go. A, B, C. So we have a triangle, A, B, C. Go ahead and draw that. Let's come up with coordinates.
1, 2, 5, 6.
I think we're at 4. 1, 2, 3, 4.
4,
1, 2, 3, 4, 5.
And then you're at 6. 1, 2, 3.
Okay, there are your coordinates for triangle A, B, C. I want you to rotate 90 degrees clockwise
Which would be
about the origin. Okay, if you go back to those equations, your mapping notation, it told you the xy will transform to be what? Negative y x. Okay, so we have a center of rotation that is the origin. Okay, so we're taking the y value and we're putting it first. So we're going to negative 2, 1.
So we graphed it like the y's and x.
This is your x, this is your y. So for A is 1, 2. It's going to map, it's going to map to A prime. You're taking the y, and you're putting a negative 2 there. And then your x is the y.
And so then that you graph that like it's an xy.
Yes, so your point, y prime, A prime, is negative 2, 1. Negative 2, 1. I think I went counterclockwise, didn't I?
That's not one. No, that's not. Wait, that was counterclockwise too.
It did. Every one of them did. Rotations are assumed to be measured counterclockwise unless otherwise turned. Let's go counterclockwise then.
And how do we do it if it's clockwise?
You're going to go a positive to negative 1. They'll just be
Flip. Mirror. Negative.
these two, the first one and the last one, will be flipped.
Yeah.
Yeah.
Lens back and forth, someone's at the door.
Okay. counterclockwise or clockwise 270, either one.
Oh, so it doesn't matter.
It really doesn't. Do you want to do clockwise?
I don't really care. So this, the little formulas you just gave us.
Or for counterclockwise?
Well, then we
Wait.
gotta count.
Oh,
So you're saying counterclockwise 90 or clockwise
clockwise
270?
270.
That's what you're saying. Okay.
Counterclockwise 90.
Oh, it's the same thing.
Yes.
They are the exact same thing. You can go
Oh.
clockwise. You could go clockwise 270 degrees and end up right there. Or you go counterclockwise 90.
But that's what the formula's for.
Yes.
Yes.
The formulas are for counterclockwise.
So there's different formulas for clockwise?
Yes.
Yes, there's a switch.
Oh, so
It's just the 90 and 270 that will switch places.
180 cents.
180 has the same thing.
Right.
Why?
So like,
Why, Anderson? Why does 180 stay the same?
Because it's in the middle, and it wouldn't matter which way you go.
Doesn't matter which way you go. Alright, so I probably need to move these pieces. Why did the top of my sheet not take? Why? Why did the top of that not move?
I thought you were actually saying like that's he.
Okay, we're gonna pretend that's safe.
No, it's not.
So this is A prime.
Whoa.
What is B?
How did that get there?
I moved it.
That is
Because I realized my shape is gonna be right
That
there.
is not what mine looks like.
Okay, what is B? 4, 5. It's gonna translate. It's gonna rotate to be where? -5, 4. So you're going back 5, 4.
Oh, they.
C, which is 6, 3, will translate.
-3, 6.
Will be negative. I'm getting close into my. Does that make sense?
Yeah, not really.
Alright, let's do this. Let's see. Let me duplicate.
Will it make a circle? Or like, the points make a square?
I mean, from.
No.
Oh no. That is not
Undo.
7.
Undo.
three-dimensional.
Ugh. Okay, so what you're envisioning, maybe I can do this. Watch this.
Oh no. It's straight now.
Ah, Why?
Why?
Oh yes.
There we go.
No, it went too far.
because it's a white center. Now I'm going to rotate 90 degrees.
It's gonna fit.
Oh, so it makes it.
Oh my goodness.
Oh,
my
it doesn't
gosh.
fit
It's pretty much like
It's so close.
It doesn't work.
Because I didn't rotate perfect.
Wait, and then why?
So we're rotating it about this. So this point,
How did you get that point to me?
I don't know, but when I'm undoing, it's not moving it back.
Oh, it's gone.
We
It's
should just
frozen.
move it forward.
No.
Go back, go back.
Here we go.
Wait, I bet it moves the dot.
About that dot.
I bet it moves the
So
dot.
it's over 1, up 2. We go back to up 1. Should those two lines be perpendicular to each other?
Yeah.
What?
Should they have opposite reciprocal slopes? Okay, let me stop touching. This from the center. Okay, stop. From the center, from the origin where we are rotating. This line is up 2 over 1. It's a slope of. Two. From this point to this point should be the opposite reciprocal. It's negative. It's up 1, negative 2. So these 2 points
Whoa.
should hit
At 9.
They asked
at
us-
a 90-degree angle.
They were gonna ask us
No.
the distance between a prime and
No.
a negative.
No, never gonna ask you that. Okay? This is just logical why they are there. 90 degrees, it will have to have a perpendicular slope.
Oh.
Could we do that with every single point?
Yes.
Yes, are we going to?
No.
We could, but we're not going to. So I'm gonna take this shape. Yes,
So
ma'am.
if it was like a 180, it would be just a straight line between.
Yes. They would have to be on the straight line and it would have to be right here. Okay? Because it's a straight line. Alright, so this, I'm going to go ahead and put A right there.
What?
And then I'm going to take, no I'm not.
You have to do the rotate button.
I'm going to have to do this one. But it's going to just turn it.
You just turn it and then move it.
Well, I tried that last time. And you guys
Can get
didn't
to where
like it.
it'll rotate on a point?
Second time's the charm. That's what they say.
That's not what they say.
It's usually the second time.
They need to make it rotate upon a point.
It's the second time. from
No,
the
it's
first
not.
one.
All of
Just like the two.
Oh, it's
Oh my god.
What do you have?
No.
Why am I rotating that?
Now you gotta fix the 7. You gotta fix the blue.
I know. It's the blue one is good.
You can make it.
Hey, almost. Not quite.
It's pretty much there. If you drew the triangle perfectly, it'd be
Pretty much kind of sort of is.
Pretty much, kinda, sorta is good.
Well,
Sort of.
pretty much kind of.
Sort of kind of.
Okay,
It's
you know
like
what
that
makes it
commercial.
perfect?
It's like that commercial. Just
Right there. That makes it perfect.
Whoa.
But then it's not existent.
It's like that commercial. Just okay. It's not okay, Miss Evans.
It's one of those people who wish for peace on the whole earth. Everyone just dies.
What do you want from this world? I mean, would that ever work though? Would anything?
No. All right. So if we are rotating something about the origin, those are the pieces that you need. Either your X or your Y will be flipped,
Excuse me.
okay? One of them will be negative, okay? All the 270 and 90 degrees, your X and your Y are flipped. To be in the third quadrant, you know the X's have to be negative, Y's are positive. To be in the fourth quadrant, the X's are positive and the Y's are negative. It should make sense when you see it.
That does make sense.
And 180 degrees, your X's and your Y's just both become negative. They stay in the same order, but it's just negative X, negative Y.
Will it ever ask us, like, on the test to do a rotation that is clockwise? Or will it just...
I think most of them are counterclockwise.
Yeah.
Alright, on page 512, some of these things I have starred because it's kind of important. If you're rotating a figure, alright, so I'm speaking. Rotating, if I need to declare that every time, damn it. Rotating a figure about a point that is not the origin can be more difficult. For a 180 degree rotation, which is still the only one that they're going to ask you to do on this scenario, is still a simple transformation mapping given below. If the point XY is rotated 180 degrees about the point AB, they give you a mapping notation. So 180 degrees about a point AB. Okay? So AB is the point you're rotating it around. Okay? You're going to have a mapping notation. Your X, Y, your point will move. Okay? It'll be 2 times A minus X. And then 2 times B minus Y.
How are we supposed to remember this?
With your brain.
What if your brain is with the green?
And And they specifically, I mean, they're not gonna ask you crazy ones on this. I think the only ones we did was in homework.
What's AB?
It's the point you're rotating it about.
The coordinates of that point.
Yeah. So, okay, let's go ahead and draw. This is why I chose to do this when pretty much everybody was gonna be here.
Except for Lance.
Well, I know I didn't know she wasn't gonna be here till today.
Where's she at?
Doctor.
Doctor.
So, when my GCU people were going on Friday, I chose not. Alright, so I give you a -3, 2.
You could.
Okay.
Indeed.
-3, 2. And I want you to rotate just this one point. This one point W. Around about point 2, 1. Okay? You're taking this point W and you're rotating it about the point 2, 1.
Does that change?
180 degrees.
I'm sorry.
Yes.
Never mind, that answered my question.
Okay. So what will W prime become?
It will become.
Wait, I don't want you to say it right now out loud. I want everyone to work on it. Go.
Does that point matter with the notation? Or do you just do the equation?
What's X in the formula?
What do you think X is in the formula?
Okay, everyone just got it.
Wait a minute. Oh no, I get it now. I'm with you, Linus.
Oh.
Makes so much sense.
I just made it more confusing.
Okay, Dalton. This point right here for W. What are these two things? What do they represent?
A dot. Where the dot is this.
Okay, let's be a little bit more specific. Okay, what is this? What does that represent? X. What does this one represent?
Y.
Y. Over here, when we're rotating it about a point, what do these represent?
A and B.
A and B.
Thank you, Eli, and whoever else. That's the point you're rotating it about. Okay? Then you go up here and you plug in where you see an A, you plug in the A. Where you see an X, you plug in the X. Where you see a B, you plug in the B. Where you see a Y, you plug in the Y.
Yeah, where that.
And you get new coordinates for
where the
W.
about point was, Lydia's head was blocking it, so I didn't see that. Gosh,
Lydia.
It makes so much more sense now. That I see it.
No. It's what you get for sitting in the back.
Ooh.
What if you just weren't paying attention? I was
Oh, let's just go to that. Thank you, Lydia.
This is practice.
Stop.
Okay, I think.
Wait. Landon, walk me through. How are we getting our W prime?
Well, if you want it, you're rotating 180 degrees.
Okay.
So you plug in X and Y, which is -3, 2. You do 2A minus.
Well, no, I'm not putting letters. I'm only putting numbers.
Oh, so then you do 2 minus -3, and then 2B, which
Is there a comma?
Oh, yes, comma. 2 times 1 minus 2. And then you plug it in.
Okay, so what is our W prime? I forgot my W prime. What's your W prime?
W prime is -270.
What? Thank you, Gray.
70.
Do you see where you got 7?
Yeah.
No. Do you see
Oh,
Landon?
because it's
2 times 2,
Oh, yeah.
4,
And then it's negative,
minus
so it's positive.
-3.
Okay.
see. Bye, Casey.
Oh, and then it's 2 minus 2, which is 0, so it's
7, 0. So you're going 3, 4, 5, 6, 7, 0.
Oh,
Okay, should it make a straight line?
Yes, it should make a
Indubitably.
180 degrees. So you went down 1, right 1, 2, 3, 4, 5. So you should go down 1, 1, 2, 3, 4, 5. Should make a straight line. So could you have simply found the slope from W to the point you knew it could? Okay, so logic. Okay, you always need to know the longer way to do it. Little hint. Algebra 2, you will always learn the hard way to do stuff, and then they'll be like, oh, you could just do this.
And you'll be like, why didn't you tell me that to start with?
It doesn't help.
Remember that time your geometry in the sevens taught us that?
Yes. And I will continue to tell, you'll continue to learn things the long way first. Once you learn the short way, you're never going to learn the long way.
Exactly.
Kind of like in
No
logic.
use in learning the long way.
Okay? Until you have to use the long way. Alright, last problem. Since I'm talking now. Example 3, the last problem we're going to look at for amusement parks. Look at the Ferris wheel at the right. Find the angle of rotation that transforms M to M prime. And explain how they got there. So they went from M. Does everybody see that point M?
Oh, that makes so much sense.
And we're rotating it all the way to M prime. How in the world might we find from one cart on that Ferris wheel to the other cart on the Ferris wheel?
Count how many there are. and
That's
then
what I
divide
did.
that by 360.
Yes, you're going to count how many carts are on the Ferris, how many spokes are there. There are 20, right?
Nice.
I would like to know
I thought there was gonna be more complications there.
It is not.
There's 20.
Attaboy, Dalton.
Good job.
Yeah, call
The spokes divide the wheel into 20 angles of 18 degrees, 7 places counterclockwise, so it moves 126 degrees. So from M to M prime, is there 7?
Yes,
4, 5, 6, 7. There are. What is the angle? Alright, so today, I question on, do we need to do A, B, and C?
I don't think so.
I think
That actually made a fair bit of sense.
Okay.
Yeah, I actually understand.
You got a few minutes. Work on your practice test from last week.